Welcome to exercise 5 of chapter 15. This and the next several exercises are focused on linear discriminant analysis, which is commonly abbreviated as LDA. In this exercise, we will generate and visualize data that we use for the analysis. And then in the next exercise, we will implement LDA without any special toolboxes to make sure that you really understand the mechanism of LDA using generalized eigendecomposition on covariance matrices. And then thereafter, we will use the scikit-learn toolbox to implement LDA with less code. So basically, we'll be using Python functions to implement the analysis for us. Okay, so let's see. The goal of this exercise, exercise 5, is basically to create data and visualize it as shown in figure 2 of this chapter. So let me first briefly explain how to create these data, and then I'll show you figure 2. Okay, so we want a data set of correlated data that have 200 observations and 2 features. And basically, we just want this to have 2 features, so it's 2-dimensional, so that it's easy to visualize. So you take the second dimension and add it onto the first, and that imposes the correlation between the variables. Okay, so that is how you create one set of data, just 2 normally distributed variables, add one to the other. And then you create a second set of data in exactly the same way, but here you add an offset so that, you know that the average of these 2 features will be 0 because we are generating these as normally distributed numbers. And then you want to add an XY offset to the second data set so that the average on the X dimension is 2 and the average on the Y dimension is -1. And then I suggest, just for convenience, to put these all into one big matrix. They have 400 by 2. And then this creates all the data set into one NumPy array, so one matrix. And then what you want is a 400 element vector of class labels. So these are fake data, so we're just, you can call them A and B, class label A and B. I called them 0 and 1, but it is kind of arbitrary. Okay, so with that in mind, let me now show you figure 2 of this chapter. Okay, so here we have the original data. So this is data, I call it axis 1, but you can think of it as feature 1 and feature 2, or measurement 1 and measurement 2. You can see there are 2 data sets. One is plotted in blue, the other is plotted in orange, and they are correlated with each other. That's what you get from adding the 2 normally distributed numbers together. And, if you would take the time to count all these individual dots, you would find 200 of them for each of these colors. So 400 dots in total, 2 features. Here you see them being plotted in the data space. And here you see the marginal histograms. And what you can see is that it is not possible, or at least it's not a good idea, to try to separate these 2 sources, these 2 data sets, based on their projection onto data axis 1 or on data axis 2. So the histograms are largely overlapping for both of these data sets. So that means we need to find some line that will optimally separate these 2 classes or these 2 categories. That's what you see here. This is the result of the LDA. Now, don't worry about this for this exercise. This comes in the next exercise. So the goal of exercise 5 is just to produce this plot here. So here I specify 200 data points, and I generate class 1 as random numbers of 200 by 2. And then you can see that I'm adding class, the first column, so X feature onto the Y feature. And this is what introduces the correlation structure, or that tilt in the data cloud. Okay, and then actually here I'm creating this offset here. So this is using broadcasting addition, which I introduced much earlier in the course. So I'm specifying here a NumPy array, and this is a matrix. But Python will analyze this statement here and see that we are trying to add a 2-element vector onto a 200 by 2 matrix, and so it will just add these to the column. So all the x-axis values have 2, and all the y-axis values have -1 added to them like this. Okay, and then here, class 2, you can see these two lines of code are the same as these two lines of code. Class 2 is going to have an average of 0 and 0, so it's going to be clustered around the origin. And class 1 will have an average of -2 and -1, so it will be shifted off the axis. Okay, and then here I just stack them together to create one big data matrix. This will be of size 400 by 2, 2 because it's the same two features for both these data sets, both these classes, and then, yeah, 400 because there's two of them. Okay, and then, yeah, here I have the vector of labels. So it's pretty easy just to give them zeros and ones. I said you can call them A and B or X and Y, but having these class labels be dummy coded as zeros and ones is generally a good idea. So 200 zeros, 200 ones, and then I append them together to have a 400 element vector of labels. Okay, so that's it. The rest of this is just visualization using Seaborn with join plot, and that you see here. Very nice. So this is the end result of exercise 5, and then the goal of the next exercise, which will be in the next video, will be to implement the linear discriminant analysis.